Hello, everyone. I hope you guys are all having a great day, or night, or afternoon, wherever you guys are tuning in from. And I hope you guys are really excited for today's workshop. It is the sixth and final one in the Encode X Rootstock Educate. We have a really special one today. We will be having Dan Nolan from Alchemy, who will be giving his workshop to all of you guys. I'm just inviting him on stage. Hello.
Hey, everyone.
Great. Whenever you're ready to share your screen and begin, the stage is all yours.
Awesome. Okay, cool. Yeah, let me know throughout this workshop if you guys have any questions. I'm going to keep the chat over here. So if you have any questions throughout, I'll definitely be taking a look, and I'd love to dive deeper into things that are super interesting to you guys. Simon had to do 3 CAPTCHAs to get in. That's a lot of CAPTCHAs. And the CAPTCHAs are getting harder too. They are definitely every day. I feel like the CAPTCHAs, I may not be by 2025. I don't think I'm going to be smart enough to be able to do the CAPTCHAs we have for next year. Okay, cool. Let's go ahead and dive into this workshop. Yeah, I'm super excited here today, guys. So, I'm going to be talking about EVM development here. This is something that has been near and dear to my heart for a while. I've been developing in the EVM ecosystem for, I don't know, I guess now 8 years. So when they first allowed smart contracts on Ethereum, it was shortly after I put in a project. It was called ETH Capsule. And I had a bunch of my friends and family. You could create these little capsules where you could put in your ERC-20 tokens and your Ethereum, and it would force you to hold it for a certain number of years. And so I still have friends and family that have these capsules that are, quote unquote buried, where they have to hold their tokens for many, many, many years, which was just kind of like a fun, interesting project that we had launched at that time. So I've seen the EVM ecosystem evolve a lot in terms of tooling. The really awesome thing here for Rootstock is by being an EVM compatible chain, you could take advantage of all of that development that has occurred over those 8 years of EVM development and be able to use the latest and greatest tools. So that's what I'm going to be focused on here today, is teaching you the latest and greatest tools. I know that for a lot of you, you're still beginning, you're still getting that foundational knowledge. So I am going to be taking things a little bit slow here. For some of you that may be review, for some of you that may be, the first time seeing this stuff. So I hope that both of you get quite a lot out of this, whichever side you happen to be on. And then for the latter part of the workshop, we're going to be going into the technicals, actually diving into the tools and building something cool, building a web application in the fastest and funnest way that I know how today in the EVM ecosystem. So super excited for all of you to be here, and feel free again to ask any questions as I go throughout. All right, sweet. So I'm going to go ahead and share my screen. Let's jump on into it. Going to do this screen over here, the infinite mirror. All right, let me switch up a few things. Okay, cool. So from the get-go, what I'm going to start out with is there's this tool called Excalidraw, which I'm going to delete my previous thing here, and I'm just going to draw some stuff. This tool is really nice in that it's going to let me just show you guys what I'm trying to accomplish here today on a high level. And I want to just be able to show it to you so that you can understand. I don't want to just jump into the code and lose people and not understand the high level of it. For some of you, if this is your first time really developing in the ecosystem, you may be sort of you need more of a map. You need more of a guideline, a directional, to understand where everything is and how everything ties together. So I'm hoping that this can kind of serve as that map for you. So when I first started developing in the EVM ecosystem 8 years ago, we really had to do most things by hand. Not everything. You didn't develop a compiler yourself. There was certainly the Solidity compiler. But outside of that, what you ended up with is you would create these projects, right, where you might have a folder called contracts. Inside of your contracts, you might create a Solidity contract, or maybe you create a Viper contract. And basically what you're trying to do is you're trying to get this contract, which is really just a program, right, that we're going to put on the blockchain. You want to get it on a blockchain somewhere. So you put some stuff inside of it. In my case, 8 years ago, this was a capsule that locked in your tokens, your Ether, for a certain number of years. So there was some logic in here that said lock in X number of years, and after that, let people withdraw, right? And there was a bunch of code in here that basically allowed people to do that. And you could create your own capsule. You could sort of dig it into the ground, and many years later, you can go ahead and withdraw that out. And, you know, ideally that forced you to hold over a period that maybe you might not have otherwise, because you would have been tempted to pull this capsule out of the ground. So this would be like a capsule.sol, right? And so to do this many, many years ago, what you really would have had to have done, and there were some tools around there, but they were all still sort of beginning. What I did back then was I took this and I put it through the Solidity compiler. So the Solidity compiler on your command line would be called solc for Solidity compiler. And what you would do is you would say, solc, I want you to compile this contract, right? And maybe you had multiple contracts that kind of stitched together through imports or whatever. And you say, hey, I want you to compile this. And then you're trying to get something specifically out of this compilation process. The things that you're trying to get out of this compilation process, there's actually a lot of things that will come out. These are typically referred to as artifacts, things that come out of the compiler. And the things that we really want to get out of the compiler are going to be really, maybe I'll just do artifacts like this, are going to be the bytecode and the ABI. So the bytecode is going to be the raw code that's actually going to live on the blockchain. So the blockchain doesn't actually know anything about Solidity. Like an EVM blockchain, it's kind of surprising, especially if you're just coming into this ecosystem, but an EVM blockchain doesn't know anything about Solidity. If you tried to tell an EVM blockchain, hey, there's this keyword in Solidity called contract or a uint or, you know, a mapping, it doesn't know what those terms mean. It only speaks in bytecode. It's a virtual machine is what it's called. And it has a bunch of these opcodes that it understands. So in order to actually get something onto the virtual machine, you need to compile it down into EVM bytecode, EVM opcodes, that it could then take these opcodes, and they're really, really simple operations like add and subtract and move memory and store stuff in storage, stuff like that, where you give it like the command and then you give it the operand, the thing that you're trying to operate on. So maybe like an example of that might be, we have this lock-in for X number of years. You might be sending over a variable that says, hey, I want you to store on this contract inside of the capsule that it's going to require 5 years for them to wait, and then they can withdraw. So in the bytecode, you might have something like this, store 5, right? And the store is actually the opcode. To the actual bytecode itself, it looks more like a 0x86, right? This is like a hexadecimal command, whatever it is. And then the operand would look like this, and that might be a store. I actually don't know the EVM opcodes by heart. Hopefully that doesn't disappoint you. So that's not actually the store command, but you could look that up. If you want to know the actual opcode, you can go find it on EVM opcodes, just like a great GitHub repo. And the Ethereum Foundation also puts up like a great website to look that stuff up there. You can find that. So yeah, so this is what bytecode might look like. So really what you're trying to do is you're trying to take your contract, you're putting it through the solc, the Solidity compiler to get this bytecode. And the bytecode is your raw program, how it's going to be deployed to the blockchain so that it could live there and it can interact, people can interact with it through websites and applications, games, whatever. And then the ABI is going to be the way that you can actually like interface with it. So we're going to see this in a moment, so that might be a little bit easier. But the ABI looks more like this. Like it looks more like withdraw takes 2 arguments, right? Maybe one argument. It takes an address who you want to withdraw to. And the ABI would look a little bit like this. It basically tells the programmer or a library, what are the functions I can call on the program? What are the entry points? How can I interact with this program? So you really want these 2 things. You want the thing that's going to be actually deployed on the blockchain, and then you want the thing that's going to tell you how to interact with it, right? You want to be able to tell people you can withdraw, and you need to be able to understand how to formulate that request so you can actually interact with the raw binary information. That's why it's called a binary interface, right? You're interacting with binary bytecode operands, opcodes, and you want to be able to understand how to formulate that request to the program, right? This is all very low level stuff, and I promise as we go through this, it'll start to be easier as we look at the more high level tools. and how we can build Web3 applications in the fun way today. Okay, cool. So that is that then. Maybe I'll just leave this here as a reminder. So the bytecode really refers to this, and then the ABI sort of refers to this thing that's like the map of the program. So these are the artifacts that come out of the compilation process. Once you have these things, what you need next really is you need a way to be able to deploy these things to the blockchain. So the next thing you really need to do is you need to write some programs on your computer that are going to then deploy these things to a blockchain, right? So in my case, I might have written something in like JavaScript or TypeScript, maybe something called like deploy TS if it's a TypeScript file. And this deploy TS is probably going to use some sort of a library. If it was 8 years ago, it was probably Web3.js. That was really the only one around at that time. And Ethers came a little bit later down that line. And now we have VM too, is a great tool. And so deploy.ts would write out a bunch of logic that would basically take in the bytecode in the ABI, these artifacts, and it would say, okay, I'm going to go deploy these to a chain. Now, there's another thing that needs to sort of happen here, right? If you're going to deploy things to a chain, so let's say we have like a blockchain over here that we want to deploy to, somebody needs to pay for what's called the gas to put this on a blockchain, because with a blockchain, you are storing this code on a bunch of people's machines for potentially all eternity, right? A whole bunch of machines are always going to host this code for you. They're going to allow people to interact with that code potentially forever. And in order to do that, you need to pay some sort of an upfront cost, which is going to be measured in this like gas that you pay. So what we need to do there is we actually need to have some balance. We need to have some money that we can use to go ahead and deploy this to pay the gas. So you might also have like a configuration over here, right? And your config is going to have things like it's going to know the chain, it's going to know your private key, so that's going to be the thing that it accesses your balance through an address. And this needs to be written in a config. And there's a whole bunch of best practices that you should be using when storing private keys and being able to like deploy that and do all that stuff. And you're going to need a library to translate that private key over into an address, but also to sign transactions. You need to do that through an elliptic curve digital signature. And all of that needs to happen within this, deploy TS and config TS, usually with the help of a library. Once you have that down, then you can go ahead and deploy this. And you might do this through, this is really where, if you see next to my name tag, I have Dan Nolan Alchemy. This is really where Alchemy comes into play here, is when you want to go deploy this, you would interact with like an Alchemy RPC node. An RPC in this case stands for remote procedure call. There is a specific set of calls that you can make interacting with a blockchain. It's the Ethereum node API or EVM node API. You can look it up to be able to see what are the different methods. In this case, you would send like a raw transaction to the blockchain to deploy the smart contract. So you'd interact with this RPC, and then this RPC would then go ahead and deploy your program to the blockchain, right? And this is really where we want it to be. We wanted to have our code up here that says, this is like our capsule, right? The capsule is that thing that I was talking about earlier that I said that I like deployed, some code many years ago that people could then, dig these things in, and it has this like bytecode and ABI that we deploy to the blockchain. You only deploy the bytecode, the ABI lives with us so that we know how to interact with the capsule in the future, right? So this is how you would set up all of this. Now, not only when you're developing a smart contract, not only are you doing all of this, right, from scratch, but you also want to do some sort of testing, right? And testing many, many years ago was not something that was super easy. You would need to, there's a whole set of things that need to happen for unit testing as well, where you would need to also then go get your own like unit testing library. So maybe you would have like Mocha.js, something like that, right? Mocha.js, you would need to go get like, so you would need to run your own local blockchain node, because you don't want to like test on a live blockchain, even a test blockchain, because every time that you use a test blockchain, which we'll do in a moment, we're going to deploy to Rootstock Testnet. Even if you were going to use a testnet, you still have to pay for gas with your private key, and you have a limited amount of gas that you can get from a faucet every day. So for unit testing, you want some way of basically being able to run some tests against a local blockchain, resetting it every time that you run this unit test. And this whole setup is a whole nother thing that you would have to do in order to basically get a good environment to iterate on smart contracts and deploy them. This whole thing is pretty complicated. Fortunately, we got some tools that help us do all of this stuff that make it really, really easy for smart contract development tools. So the two big ones now in the EVM ecosystem are Hardhat and Foundry. Truffle was also a long time tool that some people still make use of here. Hardhat is the one that we're going to be taking a look at today to be able to do some smart contract development. So all of this stuff that you see in here is baked into Hardhat. Even more than this, as we'll see in a moment. I won't go too deep into the features, but it's going to handle all this stuff for you. So it makes it a lot easier to do this sort of thing, albeit there's a bit of a learning curve. If you want to learn more about Hardhat or Foundry, for Hardhat specifically, you can go to hardhat.org. And then this is going to give you like all the documentation, how to get started. I'm going to kind of speed run that in a moment. So this is basically Hardhat and what it does for you, and Foundry and smart contract development tools. This is a really good way of kind of, we'll call them like smart contract development tools for like your whole like development suite. Now there's a whole like other side to building Web3 applications that, depending on where you're deploying to changes, right? Like if you're building an app for a phone, or you're building a game, or you're building a web application, you may need a whole nother set of tools, which is going to be like your application tools, right? So like over here, if we're trying to build a web application, you're going to need a whole bunch of stuff here, right? Like what are you going to use? You're going to use maybe like React, maybe you're going to use Next.js, maybe you're going to use like Tailwinds, right? And then you also need to over here like configure your chains. You need to do some sort of way to like connect the wallet. So if you're familiar with like browser extension tools like MetaMask, or mobile wallets that you might have, so there could be like other mobile wallets and stuff like that, you're going to need some way to be able to connect to those wallets to be able to then allow users to do things. Like if they want to bury a capsule, you want to be able to create some sort of a UI for them to be able to do this. And you're going to need this bytecode stuff from your smart contract development. Maybe not the bytecode, although in this case, actually, I do remember I did put the bytecode in the front end because I wanted users to actually deploy capsules. That's what they did. They actually deployed the capsules from over here. So more users could deploy capsules, and then you could withdraw those capsules later using the ABI. So this actually goes and deploys them. So you actually do need the bytecode and ABI over here in this case, because you actually want people to deploy them. And what else do you need in the web application? I mean, whatever you need to really deploy the whole, or to run the whole thing, right? For anyone who's built web applications before, you've probably pulled in a whole lot of libraries, a whole lot of things that you would need to do web application, right? Front ends are getting increasingly more complex as we're building these more amazing front end user interfaces on the web. So this whole thing right here looks like a lot of stuff that you need to build. Fortunately, there's a tool that we're going to be taking a look at, which is Web3 applications in the fun way. There's a tool that is super fun called ScaffoldEth. So I'd recommend for anybody who is excited about doing this sort of thing, building a web application, doing smart contract development, to take a look at ScaffoldEth.io. So ScaffoldEth is everything that you need to build all of this, everything that you saw here. Basically, it incorporates all of this, right? And there's a lot of stuff here that I didn't even really include, right? This is sort of the high level. There's a ton of other features that are going to be baked in here that make it much, much easier to use. So this is what we're going to be focused on here. Cool. I wonder if we have any questions from the beginning of that. Otherwise, I'm going to jump right into development. Let's see how we did. Oh, sweet. Worth the captchas. Okay, I love it. Wish I had a Bitcoin capsule back in 2010. Yeah, that's true. And then bytecode is to C, what ABI is to .h. Sorry, Matthias, I don't understand that question. So we're going to get into the code. That's what Gabriel's saying. Matthias, if you want to rephrase the question, sorry, I'm trying to understand it, trying to parse it, but I don't get it. Cool. All right, so let's go ahead and jump into the code. Let's start here. So if you're going to use ScaffoldEth, they've now made it really easy. So if you're familiar with tools, a lot of this workshop is going to require some prerequisite. If you're not familiar with like the JavaScript ecosystem, there may be a few things that I'm just going to kind of assume that like being able to use NPX and being able to start like a local JavaScript library. So this is going to be web application specific. So if you're not familiar with like Next.js and JavaScript, TypeScript, that sort of thing, then I'm not going to be covering that in this workshop, but definitely recommend you can always come back to this. This is going to be a recorded workshop. So come back to this, learn a little bit more about this. On Alchemy University, if you search Alchemy University or university.alchemy.com, we teach all this stuff. You can learn JavaScript there. You can learn EVM development, all this stuff from scratch. So won't have enough time to cover that here. But basically, this command here is going to use the NPM package manager, which is going to allow us to use this create ETH tool that's going to build us a new web application from scratch. It's going to have that Hardhat baked in for the smart contract development, and then it's going to have Next.js baked in for the front end development, and it's going to kind of glue those things together, much like Hardhat glued all the tools together for smart contract development. Cool. So let's go ahead and pull this in over here. What I'm going to do is I'm just going to say, let's do npx create ETH. That's what it was, right? At latest. And this is going to take me through a little bit of a thing here. That's just going to ask me what I want to name my project. And we'll call this Rootstock Fun Times. Because I don't know if I've named other things for testing. So you could use Hardhat or Foundry. I'm going to use Hardhat in this case. And it will go ahead and set everything up. So it's building the contract side of things. It's building the front end side of things. I saw some people saying that they love Foundry in the chat. That's super cool. I also do love Foundry as well, especially for unit testing. I've seen a lot of people use Foundry and Hardhat, which you could definitely support in here as well. Foundry is great for the unit testing. I find Hardhat to be awesome for like when you need to deploy and then also interact with your contracts, more like end-to-end testing. So you might find yourself wanting to use both, maybe just one. Depends on, Foundry is full Solidity. So you could do unit testing with Solidity, whereas Hardhat, you have to do unit testing with JavaScript. So it's a little bit more off there. So it's a little harder to get into. And then Matthias says that he was referring to some old school header files. Yeah, I did some C programming years and years ago. So it's been quite a while there. Oh, man. Yikes. Okay. Sorry, this computer's a little locked down. Cool. All right, sweet. So here we go. We're going to jump into Rootstock Fun 10, and we're going to pull this up into code. So what I'm going to be using, again, this was Web3 application development, fun, the fun way. So what I'm actually going to be using, even though my command was code here, I'm going to be using something called Cursor AI. Cursor AI is like a VS Code fork. So for anybody who's used Visual Studio Code, this should look pretty familiar. The big difference with Cursor, it's going to bake a lot more AI right in here, which is probably going to help us in a couple places. But I'm going to try to do some of this by hand, and I'll show you everything that I'm doing. But it's definitely going to save us in a few places, which will be super nice. So first off, let's zoom in here a little bit. So when you get a new ScaffoldEth project, it's going to break your repository up into two packages. It's going to have a Hardhat package, and it's going to have a Next.js package. And then up at the top level, if you're familiar with this concept of a package JSON, you can have a bunch of scripts in here that are going to allow you to do a whole bunch of things that are documented inside of ScaffoldEth and the documentation on that website. The important things for us is we're going to want to generate ourselves an account. This is what we're going to use to actually deploy this thing to Rootstock Testnet. I'm not going to run a local chain in this case. I don't think we're going to need to, because we're just going to be doing everything on Rootstock Testnet. But if you needed to, you could run this chain right here. We will definitely compile and deploy. So these are commands that we can run. And then on the front end, we're going to want to do start. And start is going to basically just run the Next.js stuff. It's going to run the front end stuff. So all this is like baked in here for you. There's a whole bunch of other stuff that's going on in here that's going to just be useful development tools and things that's going to allow you to like deploy this to Vercel or wherever you want to deploy it to. So that's all kind of like baked in there, which is super helpful. Okay, great. So let's start with the first thing here, which is we're going to go into contracts and we're going to create a contract. And yeah, I didn't come in with any particular agenda for what we want to create for our contract. So let's create like an ERC-20 because that's kind of fun. So like an ERC-20, for those of you who aren't familiar, an ERC-20 is a fungible token type. So a fungible token type is one that you could trade one for one. So if I have one pizza token and you have one pizza token, we could trade those pizza tokens, right? Bitcoin is fungible. If you have a Bitcoin and I have a Bitcoin, they should be worth the same, right? I mean, maybe if you have some like old school Bitcoin from way back in the day, and there may be some value to the fact like relate it back to that, right? That old UTXO. But typically ERC-20 is going to be this fungible token type, whereas an ERC-721, non-fungible token type. So we're going to focus on, let's do a fungible token type here, and we'll go ahead and trade that through. Matthias says, yeah, I know somebody who traded a Bitcoin for a pizza and it was a big mistake. Yeah, well, what was that exactly? It was one Bitcoin for, or no, it was like, yeah, was it 10,000 Bitcoins for one pizza? I think it was something like that, which is just an astronomical amount of money at this point. Okay, cool. So let's go ahead and do this. So what I'm going to do is I'm just going to ask AI to do this part. So I didn't want to get too bogged down into the Solidity coding. We only have a limited amount of time for this workshop. Plus, this is the fun way of doing it. We're just basically going to ask the AI to create an ERC-20 token for us using OpenZeppelin. So OpenZeppelin is, they're an awesome company that's done a ton of auditing in the EVM ecosystem. They also put out all of these contracts that are standards in the space. So you can use their contracts knowing full well that they've audited, that they've spent a lot of time on these, and they'll put out new versions every so often. So I want to use OpenZeppelin's ERC-20 contract, which we can then use and inherit to create our own ERC-20 contract. And we can put some more functionality on top of it as time allows, whatever time we have here to be able to do that. So let's say, hey, can you create an ERC-20 contract for us using OpenZeppelin ERC-20? Let's call it Pizza Token. Yeah. Do we want to have anything inside of Pizza Token? Let's add a function in Pizza Token that is called double or nothing. And if the block timestamp is odd, it doubles. It mints you double your balance. Otherwise, burns your entire balance. That's a pretty crazy thing to put into a ERC-20 contract. I'll talk about it in a moment. This is not a good way to do randomness, but it's a fun thing, and that's what we're here for, building fun stuff. We'll talk about a good way to do randomness, but let's just go ahead and do this and put something cool in there. Cool. So it's going to help me create this. It's using OpenZeppelin ERC-20. So for those of you who are just learning Solidity, know a little bit of Solidity, you can see it's creating a contract and it's inheriting from ERC-20, which is basically just taking the entire ERC-20 contract and putting it in here. And then we're just going to be able to like build stuff on top of it, like this double or nothing function. For any of you out there doing this like degen behavior where you want to do a coin flip and keep minting more pizza tokens. That's what it's here for. We're having fun. Let's go ahead and apply this. So we'll do that. Yeah. It's taking a little longer than I would expect. Let's just copy the whole thing, put it over there. All right, cool. So this looks like it's working pretty good. It's going to mint 1,000 tokens to the initial deployer. That's fine. Let's also add a function in here that allows anyone to mint tokens. So that way, when we're on the UI, what we can do is we could just mint ourselves more tokens in case we try to do a double or nothing and then we lose. We want to start from scratch again with new minted tokens. So let's do that. Can you add a function called mint that allows anyone to mint themselves 100 new tokens? Let's just do that. And then this is going to call, we probably could have done this ourselves. That's actually not too bad. It's just a function calling mint. That's just going to do 100 times this number of decimals. And cool. So you do have to be careful whenever you're doing smart contract development that you use the proper amount of decimals. for the token. In this case, the standard is 18 decimals, which I also believe is the number of decimals for the native currency for the RBTC that we're going to be using here as well. So, but decimals could be different depending on the token. You know, there are some that use 9, there are some that use 12. The decimals are all over the place, so you need to be careful there. But this is really what we're trying to do is when we deploy this contract, we're going to be minting 1,000 tokens to the person who first deploys it. And then we want to have this open function that allows anyone to be able to mint 100 tokens to themselves. So that way we could do this double or nothing. And you can see that in the double or nothing, what it's going to do is it's going to look up your balance. And then if the timestamp is odd, you double the balance. If it's not odd, if it's even, you're going to burn their entire balance. Why is this insecure? What do you guys think? For any of those who have been in the crypto space for a while, I'll let you guys think about that and put it on the chat. And if you can answer the question as to why this is not valid, I will call you out and say correct answer. This is not something that you can expect to be secure as a random thing there. I think Simon's onto it. Oh, Simon's not sure. Okay. Yeah. Nodes can mess with the timestamp. Yeah, Mohammed's got it. Yeah, so nodes can mess with the timestamp. So you could choose as a miner if you wanted to, right? You could choose to change the timestamp within a certain time frame, right? You don't have to stick to just like setting the timestamp to like the timestamp at that very moment when you're actually trying to mine the block. You can actually just change it within a certain time frame. There's a lot of flexibility there. So this is not a good source of randomness. A miner could double or nothing our pizza tokens till the end of the world. So this would not be a good source of randomness, but it's fun. That's what we're here for. If you wanted a good source of randomness, I would look up verifiable random functions. VRFs would be a good way of doing this. That's something that's a little out of the scope of this workshop. That's one way that you can actually get some randomness in here in case you wanted to do some kind of a weird pizza token where you could actually double the amount of tokens every time, which would be pretty crazy. Okay, cool. So we have our token. What I want to do is I want to just jump right into the application development and make sure we have enough time here. So I'm actually not going to test this, which I don't recommend if you are deploying to mainnet, but we are just going to be deploying to testnet. So that's fine. Let's just go ahead and deploy this. I'm going to call this pizza token over here, and we're going to go ahead and deploy it. So we're going to come into the contract. I'm going to call this pizza token. This deploy function actually looks it up by name, so you need to make sure to put that in there. For the arguments, there should be no arguments here. It's just going to mint it to whoever deploys the contract. So we don't need any arguments here. This is also something you could ask AI to do. You could say, if you're using Cursor AI, you could say, hey, could you fix your deploy function to work with my contract? In this case, I know what I want here, so that's fine. So we could say pizza token. And then instead of a greeting, that's what was in there before. We're going to say initial balance, and we're going to look up the balance of the deployer. And that's going to tell us what our initial balance is. It should be 1,000. Yeah, Matthias, Oracle would be potentially one way. Yeah, VRF would be a way to definitely doing the randomness there. So yeah, we're going to want to go ahead and look up the balance of the deployer. It's going to be 1,000 tokens if we did everything properly. Now, the next thing that we're going to want to do is we're going to want to deploy this to Rootstock Testnet. That's the purpose here that I want to set up. So in order to do this, there's a couple things that we need to do. So if you come into the Hardhat config, there's a bunch of networks listed in here. As you can see, they're like hard-coded with like Alchemy nodes here by default. So depending on the network, you could just sort of plug in the provider API key and be able to go from there. Maybe somebody could fork this in here, but right now Rootstock is not in here, I don't believe. So at the moment, we don't have that. So let's go ahead and just create another one for Rootstock. And we're going to do Rootstock. I'm just going to call it Rootstock, even though this is Rootstock Testnet. And what I'm going to do is I'm going to make this the default network. So whenever I do something, it's just going to go ahead and use Rootstock here. So I'm going to try to deploy these contracts. It's going to use Rootstock. And what I need is the Alchemy API. I'm going to go ahead and get us an RPC node that we can interact with to go ahead and deploy this contract, right? If we're referring back to that picture we saw a moment ago, right? We're in this stage. over here where we want to go ahead and deploy this, right? And we want to deploy this through the Alchemy RPC. Alchemy RPC would also live over here on the front end too. So that's kind of useful to put in there. And then this would interact with the blockchain node as well. Picture's getting a little ugly. All right, cool. So this is where the Alchemy RPC comes in, right? Whenever you want to interact with blockchain, we make it super easy to do that. You could, there's a whole bunch of different ways that you're going to be able to interact with it. One of these things is you could just use the RPC directly, which is going to be all of these commands. If you ever want to know the entire Ethereum RPC spec, you could just look it up. The best one is going to be, we could use Alchemy. Here we go. So here is a bunch of the RPC. What I'm looking for is more. Let's see if this will tell me. Sorry, we have so many pages. What I'm looking for is the methods. Here we go. I really like Ethereum's one here where we actually have all of the different JSON RPC API methods documented. So you can actually find them in here. This is going to tell you everything. So if you wanted to send a raw transaction, this would be how you would deploy a contract. Again, like I said, like before, EVM nodes don't actually know anything about Solidity. So this is actually what it expects you to send when you send a transaction. But in this transaction is actually going to be all the encoded stuff to sign the transaction, to recover your address, right? There's that elliptic curve digital signature that the nodes can then recover your address, but it's also going to have things in there like how much gas you're willing to spend, what you're trying to do. Are you trying to deploy a contract or interact with the contract? How much value are you trying to send to that contract or that person? Whatever it happens to be, that's all going to be in here. So this is a super low level call, but that's what we're trying to do. So what we need to do is we need to get an endpoint that we can use to then make those kinds of calls. And here are the endpoints for Rootstock. So this one I have set up already. You can see I sent a bunch of requests to it yesterday to make sure everything was working for this workshop. And what I'm going to do is I'm going to grab myself an API key, which is up over here. And then we can go ahead and plug this in to, what happened here? Okay, this is a different, okay, sweet. So what we could do now is we can go ahead and plug this in. So let's use something more. Okay, let's just do this. Whoops. So if you go over here to the networks, it's going to give you the actual URL endpoint, and I can pull this in. If you want to be smart about this, then you could take the API key like they did above here and put it into this provider API key variable and then put it into the .env. Maybe we'll go ahead and do that. Might as well. Provider API key, and then we could actually just grab that API key and put that in here. So let's do that. We actually want to do testnet, right? So I think it's just going to be rootstock.testnet. So you want to be careful about that. But you're not going to accidentally put money on the mainnet, right? Because you'd actually have to go pay for that. So testnet there, same URL. So we're going to do the testnet. And then for the deployer, for the provider API key here, it's going to come out of environmental variable here. So we can go to environmental variable.example, and we could clone this. Unfortunately, that just got rid of my API key that I was holding on to. So I got to go get that again. Sorry for all the screen switching. All right, and we're just going to do Alchemy API key for now. The other thing that we do want to do, and this is kind of nice, like I said, there's a lot of best practices around like storing a private key. ScaffoldEth just recently made this better, so you can actually just call yarn generate. Yarn is another package manager. JavaScript has a lot of package managers. NPM is one, Yarn is one, PNPM is one. We're going to call yarn generate here, which is going to allow us to generate a new account that's going to have a private key that links it to an address, so we can actually go ahead and have an account that can have some testnet rootstock in it so that I could deploy this contract. This is a good practice for doing your private keys locally. Even though this is just going to be for testnet, they're going to encrypt it with a private key. I wonder if I could do no private key. Yeah, all right, sweet, no private key or no password. But you know, if you actually cared about the address, then you might want to encrypt it with a better thing there. So here's my address that I can use. So this is a randomly generated address. If I want to deploy with this address, I have to give it some testnet rootstock. So let's go and give it some gas. So I can go over here to my So I have an account here that has 0.0005 TRBTC. I don't need that much here. So there are Rootstock Testnet faucets, and I used these yesterday, so they should be fine. And we could use these here, and you can plug this in. Say I'm not oh, here's the captchas. Who was saying they had to do captchas? All right. It's so hard to see which ones have motorcycles. I think they all do. All right, sweet. That wasn't so bad. That was just one captcha. They get pretty bad though. How's that invalid? Oh, there's no 0x. What? That one's been used previously? All right, I'm just going to send myself some testnet ETH, testnet TRBTC here. So, all right, so let me send over 0.0001. That's fine. And that should be plenty enough to deploy the contract. So we'll send that over. And that's going to go ahead and land over there. And then we're going to be able to, with my private key that's baked into the Hardhat side, we'll go ahead and deploy this out into the testnet of Rootstock. Sweet. So I'll give that a minute. You can also, there's a command you can run yarn account, which is actually going to allow you to look up your account and see whether or not you have any testnet Ether in there, or testnet TRBC. I just have my default thing there. So can't connect to any of those, but it should be able to find the Rootstock. Okay, I think that's just further down. So it's looking at the balance across all of these, which is taking a little bit longer. I really just want to know if we got any on Rootstock Testnet. Okay, that's all right. Let's just go and see. It should have landed by now. So if we look up on the block explorer over here, we can see this is the address that I actually have locally, and we can see that there's actually a balance there. Now I can actually use this. You have to pay a certain amount of gas in order to deploy your contract. So now that I actually have that gas inside of this account, I can actually run deploy. So if I come back over here, I can run yarn deploy. And again, this is going to ask me for my password to go ahead and deploy this out to Rootstock. And I didn't put in a password, which is bad practice. Should put in a password. But we'll go ahead and let that deploy. Look, there's a transaction already. That's exciting. So we can look this transaction up on the Explorer. If we do TX and put this in here, and it is pending. So we're waiting for it to get picked up to be put into a block. Once it's put into a block, then we will have our program on the blockchain with that crazy double or nothing function, which is kind of fun, but also very exploitable, as Mohammed pointed out. Cool. So that should be out there in a moment. It takes maybe up to 40 seconds to a minute. It'll be, there we go, sweet. So there it is. We have our contract created. Where is the contract created? Here it is. You can see it's already picked up on the pizza token, the symbol. Here's the address. So we want to interact with this contract. Now what we want to do is we want to get over to the front end side. So we have 15 minutes left. So let's make sure that we can get over to the fun stuff here. I'm going to go ahead and jump into the development side of things. Now, what's really cool here at this point in time is, oh, and look, it even told us our initial balance. It didn't do it formatted. So this is with all the decimals, but it should be 1,000, should be our initial balance. So we'll take a look at that in a moment in the UI. But what's really cool here, like I told you in our picture, so if we go back to our picture, right, this is our map of how ScaffoldEth does everything for you. It did all the development side, right? So we already deployed ourselves a contract. In this case, it's an ERC-20 Pizza Token. We did that through the Alchemy RPC over here. Now this is out on Rootstock Testnet, right? And now in our picture, what we need, testnet. Now what we need over here is we need all this stuff. This is already baked in because ScaffoldEth already has this. It has the Next.js, all that stuff baked in. It has the connect wallet functions, all that stuff. You don't have to build any of that from scratch anymore, which was always a pain. And then it's also going to take the artifacts, the bytecode and the ABI, and it's going to put it right into your web application. If you don't believe me, here it is right here. We go into Next.js under packages, deployed contracts, and you can see deployed contracts. Not only is it going to have the pizza token, ABI, and bytecode, and here's the address as well. It already pulled the address over, so I don't have to do that manually. It also specifies what chain that's on, which is very important because you don't want to be like trying to interact with the wrong chain right? So now the front end knows this is on testnet, or this is on the Rootstock Testnet, which is EVM chain 31. Each chain has a ID. You can go to chainlist.org to see the different IDs. I believe Rootstock mainnet is 30 and then Rootstock testnet is 31. And you can see Pizza Token is deployed on the testnet at this address. Here's the ABI. Like I told you, it's a series of like methods. So here's a method right here. Well, here's an error actually. And then a method might be, let's see, balance of. So here's balance of, right? And what it's saying is there's no inputs, but there is one output, a uint256, an unsigned integer. So if you called out to this contract and you ask for balance of, it will return you a unsigned integer telling you what the balance. Actually, there should be an input. Here it is. It was above it. There should be an address. So you're going to put in an address. It's going to tell you what the balance of is for that particular address. Awesome. Okay, so this is all set up actually. So I don't really have to do all that much. Again, this is web application development the fun way. The only thing I really need to do is say yarn start. This is going to start up a front end application for me. And we're going to jump in here to it. And it is going to be good to go for me. So let's go ahead and wait just a sec. Let's check the chat, see if anyone's saying anything. Don't be a rando. Yeah, you don't want to make the mistakes of our predecessors. All right, let's see. Come on. It always feels like it takes way longer to spin up like dev servers and stuff like that when you're live streaming. All right, cool. So it's getting mad because it's saying, did you forget to run yarn chain? Basically, we got to change the target network here. The target network we actually want to run this on is going to be not a local chain. So I said yarn chain is when you want to run a local blockchain. We're actually going to target Rootstock Testnet. So I want to go do that over here. So if we go to scaffold.config, we need to do chains.rootstock testnet. Now this definition for the chain is actually coming from a library called VM, and they already did everything in here. So if you actually take a look at this, you'll see the ID is 31. It says here's the native currency, it's Rootstock Bitcoin. Here's a symbol, there's 18 decimals, so I was right about that, which is good. And the block explorer and everything like that. So that's already baked in, which is sweet. So the UI can use all that stuff. That's all we have to do is change that to the Rootstock testnet. And then we come back over here and hopefully now it'll pick up on that. Wrong network. Let's switch to Rootstock testnet. So it's going to switch me over in my wallet because my wallet was pointing at a different one. And sweet. Look at that. All right, so we're on the testnet. It says I don't have any balance, but should I be connected to one that has a balance? Let's connect this one. Cool, look at that. All right, sweet. I have some balance. I have 0.004 TRBTC, and ScaffoldEth makes this super, super fun because they're actually going to make it so that the contract is already something that you can interact with from the front end. They already have this built out, like nice UI. I mean, this isn't like a UI that you might ship to a user, but it's pretty nice for the developer when you're trying to interact with your contracts to come in over here and be like, okay, what's the balance of this address right here? We're going to look up the balance. It's 0, right? Because we didn't mint ourselves any pizza tokens yet, but we might want to mint ourselves some pizza tokens. So let's go ahead and do that. Let's mint ourselves, because we minted, just to remind you, we minted some pizza tokens to the deployer of the contract. That's different than the address that's sitting in my MetaMask right now. But let's go ahead and deploy ourselves 100 tokens. That's what we programmed into the mint function. It's going to deploy us 100 tokens. So we'll wait for that transaction to complete. And because VM already has this baked into our chain definition, it knows where this block explorer is. So we can even click on this and it'll show us the transaction. It's pending. We'll wait for that for just a second. And when that comes through, we should have ourselves a balance. Yeah, that's true. Matthias is saying because I'm streaming, there's extra load on my machine, and that's why it takes so long to run the dev server. Yeah, that's fair. I just got to come up with like better jokes or things to say like while these things are happening. So that way it doesn't feel as long for you guys, even though I'm like stalling and sweating it out. All right, here we go. We are successful. So let's check out our balance over here. Okay, so cool thing here also that they have baked into ScaffoldEther is they have this like function to divide by 1E18 automatically. And you can see now it says 100. So we have 100 pizza tokens, right? And you can see it's even picking up on the total supply now. So the total supply is 1,100 because we minted 1,000 to the owner. So why not try double or nothing? Let's try it. Let's double or nothing. Can we double our money? I feel like I'm not going to be lucky here. I don't think I'm going to double my money. I feel very unlucky right now, but I'm going to try. I'm going to see how far we could take it. If I keep doubling till the end of this workshop, I'll do it. If I'm on a lucky streak, I'll just keep going. Let's see what happens. We'll see. Maybe all the timestamps are going to be odd. That would be great. So we didn't even test this contract, so maybe there was a bug in there. But let's see what the timestamp is over here. Can we see it on the block? So here's the block, right? And the timestamp. Oh, does it say the timestamp? Ooh, I don't know. There's a time. I don't see a timestamp, unfortunately, unless I'm missing it. Maybe mining information? No. Okay, I don't see it. So we're going to have to look in the UI to see whether or not we did it. All right, here we go. Here's the big moment. Did we double? Yes. Doubled. All right. Let's see what we got. We got 8 minutes left. Maybe we can get this into the front end so we could actually build these components, right? Like if you were going to build this, you would want to create your own UI. Pizza's on Dan this weekend is what Matthias says. Cool. You can see the total supply also went up to 1,200, right? So we're using that mint and burn. So when you actually double or nothing directly on the contract, it's actually affecting the total supply of this contract, which is kind of cool too. So you can actually see that automatically updated there. So what we might want to do from here is actually develop the web application ourselves. So this is where you can actually start to use the stuff that's baked into ScaffoldEth. So ScaffoldEth has all this documentation here for interacting with your smart contracts. It has these really useful hooks. So for anyone who's not familiar with React and how it's gone into hooks and all of that, don't have enough time to explain it, but hooks are just like these useful pieces of code that you can like use to like run some stuff to change your components around. That's all I'm going to use to describe hooks right now. But yeah, I'll definitely do some more development on React and check that out. These are really useful things to be able to read and write to your contract. So they're going to handle like asynchronous stuff to actually go out and do that, handle basically what's called like the side effects here, right? Because React wants to be pure. You want to have just these like things that are just modifying your components in a way that only changes when there's like state changes across the board. Okay, cool. So we have this use scaffold read contract and use scaffold write contract. Let's use one of these right now, and we'll see how much time we have left. And if anyone has any questions, feel free. I'd rather answer questions if it's interesting, but otherwise I will program in the double or nothing on our site and make it look kind of fun. So we're going to use this use scaffold read contract. And what you can see here, this is really cool. So what they've done with Scaffold is they've actually baked into the application itself all of the TypeScript types. So if you actually use scaffold read contract inside of your front end and you specify your contract, it will actually come up with the function names that you can use. And if you don't put in the right arguments or you put in the wrong number of arguments, it'll actually say at compile time with TypeScript, it'll show you a thing saying, hey, we expected 2 arguments, or hey, we expected this to be an address. It's a uint, that sort of thing, which is super, super cool. So let's go ahead and just let's show on the front end. So on the front end right now, what we have is we have welcome to ScaffoldEth 2, right? Let's change that to be welcome to, get rid of all this. And we're going to say welcome pizza token. Let's say double your pizza tokens here. Hopefully blockchains are not just for gambling. Okay. Yeah, we want more stuff than gambling, right? But that was the easy functionality to do here. Sweet. So you can see we're updating our user interface here. We want to now basically, let's show how many pizza tokens this person has. So that's going to be a good example of use read contract. So for those of you who are familiar with Cursor, what you can do is let's close everything out over here. You can give it a certain amount of context. So right now the context is it has page.tx inside of it, but I also want to give it the hook that I'm going to use scaffold read contract. And I'm going to say, hey, could you use the use scaffold read contract hook to read from our contract. Maybe I'll give it deployed contracts as well. So that way I could look up the actual contract itself and know. That would be useful. So now this is all its context. This is what it knows about. Could you use this to read from our contract the balance of for the connected address and display it in this component. Also, could you show us a nice SVG icon of a pizza? Make the balance really flashy in like a nice pizza looking font that is pizza colored. All right, that's just a ridiculous request, but you know what? It's going to figure out how to do that. So yeah, we need a React course on Alchemy. You know, there's so many good React courses. If anyone's looking for React courses, I really love Frontend Masters. They do a fantastic job there. That it's easier to stand on the shoulders of giants, let other people teach React, and then like teach you how to connect it to Web3. So definitely check that out. All right, cool. So what is it doing? It's pulling in that hook, use scaffold read contract. It is going to our pizza contract. It is looking up the balance with their connected address. And then it's doing this whole thing where it's going to show the pizza. It drew an SVG. It says it has cheese and pepperoni on it, which is cool. Let's see how it looks. All right. Let's see what our balance is. Is this going to work? I never know. Oh, no. Cannot mix big in. Use explicit conversions. Okay. So let's see. Let's just ask it to fix that. The type conversions are always a pain. I guess balance is a big int. So in this case, you want to do, what is it going to tell me to do? Oh, I guess just divide it directly and then do the number conversion. That's helpful. Let's see if that works. All right. Oh, that's a nice, look at that slice SVG. Oh man, that's pretty cool. This is a great application already. Should we do double or nothing? Do we have enough time? We have 2 minutes. If anyone has any questions, feel free. Yeah, it did come out pretty nice. All right, let's double it. Let's double it. All right, let's do, sweet. Can you also add a button? Let's do write contract, use scaffold, write contract, and let's do a deployed contracts. Can you also add a button using use scaffold, write contract to call double or nothing on our pizza token? Please make it look really nice. And if you can figure out how to, I don't know. So this one's pretty tough. I was going to ask the AI to figure out whether it could determine whether the double or nothing was successful, but we didn't emit an event whether or not that was successful. So it's going to be hard for it to figure that out. It would have to do like a balance of lookup. So I'm just going to say, please make it look really nice and do some cool animations that make it look like we're gambling. Get us very excited. Yeah. Okay, cool. I don't know what that's going to come out with, but yeah, here's a gambling function. Here we go. All right, double or nothing pizza token on click. Oh, look, it's got a rolling the dice, double or nothing. We'll see what happens. Good luck. It even tells us good luck. All right, sweet. That seems pretty cool. Yep. Did it get it all? All right, let's see what happened. Oh, no. All right, so write contract. What happened here? Is loading does not exist. That's a bummer. I don't know. Double or nothing. Does it take a different, let's check our pizza token. Does double or nothing? No, double or nothing is just a function that takes, that's the name of the function too. Argument of type. Maybe they changed use scaffold write contract. Unfortunately, sometimes the versioning stuff could be, that's a nice looking button. All right, let's just fix this real quick. I know we're coming up on the hour. So use write contract, use scaffold write contract. Oh, you plug in the name of your contract and then you get the write contract async. This is what we need. All right. Okay. I think it just read maybe the, well, it has write contract. Okay. So it should be pizza token like this. and then the function name comes in later when you actually go to call the right contract function. So this is more like, I don't think we're going to be able to get the is loading in there. So let's just call right contract and then the function name double or nothing. All right. I don't think we're going to be able to get the loading in there. Unfortunately, it had like a nice animation in there, but yeah, we'll get rid of this one. All right. So that's not going to be as nice as it would have looked. Oh no, still is loading. I should have gotten the is loading in there. That's too bad. All right, let's see. Okay, we lost the text because I deleted it. But let's see if it goes ahead and does it. Okay, so this is going to go ahead and do the double or nothing. And hopefully that'll go through. Let's see. It's not giving me a little thing telling me that it did. I'm trying to speed run too fast here, unfortunately. Did it try it? Let's see. I don't know if it tried it. We could be out there right now trying a double or nothing 11 minutes ago. So no, I don't think so. Maybe it just didn't get picked up. I don't even see. Okay, so maybe we could see. We need a better UI here because I'm not even getting. Oh, execution reverted. Whoa. Okay. Huh. Why would the execution revert? Double or nothing wasn't. Oh, no. I think maybe we lost. And the UI is just not reflecting it. So let's just go ahead and. No? Huh. Okay, that's a bummer. Oh, here we go. Yeah. So one reverted. Yeah, the UI is not very good at the moment. We'd have to get that hook right. So it thought that there was an is loading that was going to be returned by that. So unfortunately, that didn't come back. But it looks like what happened was we lost our tokens, and then the second one reverted because there's this require that says the balance of the message sender has to be greater than 0. It's not going to let you do double or nothing with 0. So I think we lost our money. No more pizza on me. All right. Well, that's what happens when you gamble. I mean, this is like the house always wins, right? You're not going to keep doubling until the end of the. Yeah. Mohammed says, good way to end it. Time to go home. We lost all our pizza tokens, but there is a free mint function over here, so you can play all day. Yeah, sweet.
Amazing. Yes. That was a great end to such an informative and really interesting and exciting workshop, Dan. Pizza is on Encode. Yes. we do like our fair share of pizza here. But thank you so much, Dan. That was a really cool, really exciting workshop. I can see by the comments that a lot of people really enjoyed it too. As always, the workshop will be recorded and uploaded to our YouTube, and I'll send it out to everyone tomorrow. This is the end of the Encode X Rootstock Educate series. I hope everyone really enjoyed it. We've had some amazing speakers. We ended on a really high note with Dan from Alchemy. Yes, Matthias, it was a really good one. So yeah, I hope everyone enjoys the rest of their day. Dan, thank you so much. That was really well done. And yeah, if anyone has any questions, I'm sure they can reach out to Dan on his socials. So yeah, thank you very much.
Sweet.
Perfect.
Thanks, Adriana. Thanks, everybody. Take care.
Bye.